For our last problem-solving technique of the semester, we'll revisit what's probably one of the earliest problem-solving techniques for you, which is algebra. And I've titled this Guess and Check Meets Algebra. When I teach algebra, I can't tell you how often students say this to me. I can solve equations, I just don't know how to find the equation. So I give them an interesting word problem and they just fall apart because if I give them an equation, they can solve it, but how do they turn the words into equations? And sometimes that's easy, sometimes it's not so easy. Some students are very comfortable just reading and going straight to equation, but lots of times people aren't. So let's look at this problem. Diane went on a business trip to a meeting that was 100 miles from her house. On the way to the meeting, the weather was really bad and she couldn't drive very fast. On the way back, however, she was able to go 20 miles per hour faster. In all that day, she spent 3 hours and 55 minutes driving. How fast did she drive on the first leg of her trip? That is, on that first 100 miles. So what was her speed? Now, if you feel like you can set this up and go straight to an equation, great, good for you. Many students struggle with ones like this, though. How do you get an equation out of this right away? And what we're going to do when we can't find an equation is to guess. So was it 30 miles an hour on that outbound trip? Now, we're not so much interested in solving this by guessing and checking, but we're going to guess, and we're going to look to see what we do to that guess, and then from that we'll get an equation. So let's look at how that works. So we'll guess that on that outbound trip, on the way there, it was 30 miles an hour. So we'll take our 100 divided by 30 equals 3.3 hours, 3.33 hours. Time is distance divided by rate. And then she would drive 50 miles an hour on the way back, 20 miles an hour more. And that would take her 2 hours. 100 miles divided by 50 miles an hour, 2 hours. Total time was 5.33 hours, but that's more than the 3 hours and 55 minutes that the problem gave us. So 30 isn't right. Now we could get an answer by guessing and checking and just continuing, but here the name of the game is to find an equation. So what we're going to do is we're going to ask ourselves, well, once she made that 30 mile an hour guess, what did she do to check whether it was right? She divided by once she divided 100 by her guess to find the time on the way there. Then she added 20 to the guess and divided 100 by that. And adding the two together, she hoped she'd get 3 hours and 55 minutes. So we will do the same thing, only we're going to get an equation by calling the guess x. 100 divided by x plus 100 divided by x plus 20 equals 3.92. And I first converted the 3 hours and 55 minutes to 3.92 hours. I did that, by the way, by dividing 55 by 60, and that was the 0.92. So again, she guessed 30, that was her first guess, and then she divided 100 by that to find her time on the way to the meeting, and then added 20 to the 30 and divided 100 by that, added them together and hoped she'd get the 3.92 hours. So when we do that with x, this is our equation. And now we have an equation. So now all those students who say, I know how to solve equations, I just can't get the equation, they can solve it now. We didn't solve it, did we? That's right. Turns out to be about 42.7 miles an hour. And if you would like to do the algebra to convince yourself, go for it. But that's not really what our concern is today. Our concern is how to take a situation, how to take a word problem and turn it into an algebraic equation when we can't just look at it and see what the equation is. So again, we guess, we look to see what we did to the guess, and by looking at that, we can get an equation.